There was an inter-college dance competition for which a few boys and a few girls were to be selected. So this is what we have with us. Out of the 10 boys and the 8 girls, 3 boys and 3 girls were to be selected. In how many ways can this be done? Let's try and understand the question well. There are a total of 10 boys and 8 girls. And out of these, we need to select 3 boys and 3 girls. The best way to understand this is by considering the boys and the girls separately. So the two cases are selecting 3 boys out of 10 and selecting 3 girls out of 8. In fact, separating the two cases was necessary. We cannot select boys from the group of girls or vice versa. That doesn't make sense. Let's first look at selecting 3 boys out of 10. Before we begin solving any permutation and combination problem, you should know if the order matters or not. Does the order matter here? To know if the order matters, simply read the statement well. Selecting 3 out of 10. Is there any other condition? There isn't. Selecting B1, B2, B3 is the same as selecting B2, B1, B3 or B3, B2, B1. We are just selecting 3. And similarly, the order does not matter for selecting 3 girls out of 8. How do we solve this problem? We haven't seen the P and C formula yet. How do we solve this problem based on logic? Okay, how about we solve this case first, then this one, and then we will see what to do. So selection of 3 boys out of 10. We know that there are 10 boys. We can select any 3 boys. To show that, we can say S 3 times. What about the remaining 7? Each of them is not selected. Out of 10, 3 are selected and 7 are not selected. And this becomes a classic case of the anagram problems we have seen. There are 10 people, so 10 factorial will include all possibilities. Now this 10 factorial assumes that each of these 10 cases is different. But that's not true. These 3 are not distinct and these 7 also are not distinct. Now how does this 10 factorial count the cases of 3 boys being selected? It assumes that B1, B2, B3 is different from B2, B1, B3 or B3, B2, B1 and so on. There are 3 factorial or 6 such ways which 10 factorial assumes to be different. But all these are the same. The order does not matter. So to eliminate the repeated cases, we divide this by 3 factorial. And as there are 7 boys that are not selected, we divide it again by 7 factorial. That's the answer for this part. These many ways in which we can select 3 boys out of 10. If you're not sure about how we got this, please go through our video based on anagrams and you will surely get a better idea. Now we can move on to the second part of selecting 3 girls out of 8. There are 8 girls in all. Using this concept that we just learnt, can you find the number of ways in which we can select 3 girls out of the 8? I am sure all of you got it right. As 3 girls are selected, we write S 3 times. And the remaining 5 are not selected, so we write NS 5 times. Out of these 8, these 3 are similar and these 5 are also similar. As there are 8 girls, we write 8 factorial here, and this includes all possibilities assuming each of the 8 cases are different. But we know that they are not. For this, we divide 8 factorial by 3 factorial, and for this, we divide it by 5 factorial. These many ways in which we can select 3 girls out of 8. Some of you might wonder why I don't solve these factorials. That's because in the exams, in all probability, your answer choices will also be in factorial form, especially when the answer is huge. And I'm sure you can solve these pretty easily to get the numerical value. That's not the important part. The important part is understanding how we got this. But wait, we have the answers for each of these 2 cases, boys and girls. What's the answer to the question? The question asks us to find the number of ways in which we can select 3 boys and 3 girls out of 10 boys and 8 girls. So do we add these two or multiply them? The question gives us the answer, 3 boys and 3 girls, and always implies multiplication. So we multiply these two and this becomes our final answer. If you solve this, you should get the answer as 6,720. 6,720 ways in which we can select 3 boys and 3 girls from 10 boys and 8 girls.